In this video, we're going to have a look at the benefits of security and governance in the cloud. So this web page defines security as confidentiality. In other words, you have your data and nobody else has it. Integrity, you have all of your data. And availability, you're able to access your data. Now, when it comes to the physical components, they are secured, they are maintained by Azure. So they are in some buildings somewhere, you don't have to worry about them. Other components, such as the operating system, such as data, may be secured by Azure, or you might have to do things for yourselves as well. For example, if I let somebody else have access to my data, then it's no longer confidential, but that's down to me and not down to Azure. Now, security is a combination of lots of things, such as identity and access management. So you'll be authenticating users, making sure that they are who they say they are, and authenticating devices with directory services such as Azure Active Directory, and we'll be looking at that in later videos, together with social media accounts such as Facebook and Google. There's threat protection, so identify threats, attacks, vulnerabilities, and also countermeasures to those threats. Information protection. Protect and classify sensitive data using access control and encryption. So only some people are able to gain access to the information that they need. The data is encrypted, which means that nobody else can read it without the encryption key, without being able to unlock the code that has been used. Insider risk management. So authorizing users to only access the services and data that they need. Now, the other part of this video is about governance. And what does governance actually mean? I mean, we sort of know what security means, but what does governance mean? Well, it's the process of checking that everything is working. So compliance management, for instance, is your system capable for meeting your requirements, your regulatory requirements, your national requirements, your trade-specific requirements? And then we've got other things like discover and respond. So what are the threats and how do you respond to them? So the benefits of security and governance in the cloud. For security, your data becomes confidential, integral, and available. And your governance is the process of checking that everything is working to your regulatory requirements. In this video, we're going to have a look at the benefits of manageability in the cloud. So you can see we are in the Azure portal and I can manage all my resources here. Now, we've had a look in previous videos about how resources are organized. So resources are organized into resource groups. So I've recreated some of my resource groups for this video. So here is a virtual machine that I had previously deleted. And here you can see all of the resources in this particular resource group. Now, resource groups are contained in subscriptions. So if I go to my subscription, here we can see my free trial subscription, and I can manage my subscription. I can see what the latest build amount is. I can see my invoices over time. And subscriptions are managed in management groups. So we had previously set a few additional management groups. Now, security permissions are cascaded down through these levels. So if I go to a particular management group and I add some security to that management group, then that would be cascaded down through the subscriptions in that management group, and anything in the subscriptions would be cascaded down to the resource groups, and anything in the resource groups would be cascaded down to the resources. So just by altering security at the management group level, it will go down to all of the resources there. Now, I can manage everything here in the Azure portal. There are other ways of managing, and we'll be looking at some of them, like the Azure PowerShell and the command line interface, or CLI, later on. And with something called Azure Arc, which again we'll be looking at later on, you can add additional non-Azure resources to the Azure portal and other methods. So you can manage them just as if you had them in Azure. Now, I'm in my office, but I could be in a completely different office. I could be in Australia, for instance, and still be able to manage my resources as long as I can authenticate, as long as I can say it is really me. I log into the portal, portal.azure.com, I say it's me, and then I get all of the permissions that is associated with my account. So one thing that I can do in terms of managing is add security. I can delete resources, I can delete resource groups. So we had a look at earlier about how to delete a resource group. You type the resource group name and that deletes the resources. So it's not just individual resources just lying around anywhere. I can have them in a resource group and then I can affect everything all at once. It makes it so much easier to manage. So the benefits of manageability in the cloud, I can access it from anywhere, and my resources are contained in resource groups, which are contained within subscriptions, which are contained within management groups, so I can go to an appropriate level and manage them from there. So I use the same interface each time, so I don't have to learn lots of new interfaces to manage. I can quickly go to whichever resource group or subscription or management group or resource I want to have a look at, and then I can quickly and easily do what I want with it. So this is how you can manage in the cloud. In this video, we're going to have a look at the differences between capital expenditure and operational expenditure. So we've had a look at the total cost of ownership calculator earlier. So this compares on-prem costs with Microsoft Azure costs. And you can see they are broken down into various categories. So the on-premises cost, we've got hardware. Hardware, so these are the physical computers you have to buy. Now suppose we have a 3-year project and I want to use it for all 3 years. Then I have to buy the hardware right at the beginning. So it's an upfront cost. I can't purchase it halfway through if I wanted to have used it for all 3 years. So let's say I've got a server costing $10,000. Can I write those $10,000 off tax in that year? And the answer generally is no, I can't. I would have to do something called depreciation. So I would be able to get, say, a quarter of the costs off in the first year. So I'll be able to say $2,500 I'll take off my profits. And that gives me a pool of $7,500. Then in year 2, I'll be able to take 25% off the $7,500. So about $1,800. So I can't take it all off profits in the first year. The money is spent this year, year 1. Yes, I will be having this hardware for year 1, year 2, year 3, but I've got to have spent it right here, right now. So what is the good side of capital expenditure? Well, I know what I'm actually spending. So I have this hardware cost and I go to the shop, I spend it. I don't have to purchase another computer unless I want to scale up or scale out or whatever. I know what I'm spending. Now, operational costs, you've got this both in on-prem and Azure. So software might be a capital expenditure. You might have to purchase some expensive software right at the beginning, and if it's really expensive it might be depreciated. Alternatively, it might be a capital expenditure. So this is money spent on goods or services right now and build now. Electricity is an operational expenditure. IT labour is payroll. I would also count that as an operational expenditure. So operational expenditure, or OPEX, is usually deducted against profits in the current year. Now it may be possible, for instance in reserved instances, to get 1 to 3 months worth of compute power right at the beginning and pay for it in year 1. Can I deduct it from year 1? Maybe not. I might have to spread it across the 3 years that I'm going to be using it. But this is spreading rather than depreciating. So I've got a third in year 1, a third in year 2, and a third in year 3. I don't have to depreciate it by 25% and then a further 25% of what's remaining and so forth. So if I spend in advance, then I might not be able to deduct against profits in the current year. Disadvantage of OPEX, operational expenditure. Well, this compute, for instance, I might decide I suddenly want more compute, or maybe the networking changes. I'm getting more egressing network going from one zone to another in the world. Or maybe I need additional storage. So the money being spent may vary from month to month. It depends on what resources are used. So capital expenditure, an initial payment that can be depreciated over time. Operational expenditure, money spent on goods or services now, billed now, and unless it's an initial payment for several years, it's usually deducted against profits in the current year. In this video, we're going to answer the question, what is the consumption-based model? And to do this, I've gone back to the Azure pricing calculator. So if I provision a virtual machine in this pricing calculator, you can see that it is being charged, if I go right down to the virtual machine, by the hour. So we have got a CPU multiplied by 730 hours. If I was to change that to 100 hours, then the monthly cost decreases as well. So you only get charged for services when you use them. Some services, like for instance storage that comes with my virtual machine, gets charged for the provisioned or the reserved capacity. In other words, I want this many megabytes available to my virtual machine, it will cost you this much. Now compute services, go back to the virtual machine, can vary quite enormously in terms of processor power and therefore price. Now, how can we get to 100 hours? After all, if there's 730 hours in the month, how can we only get to 100? Well, maybe we only want to use it between 8 AM and 12 noon, for instance. Now, this can't necessarily be done with a virtual machine without you actually creating it and then deallocating it. However, as we'll see later in the course, this sort of functionality is actually quite useful and can be done with something called dev test labs, so you can provision it and then unprovision it automatically. Now, you can also have reserved options. So you can reduce the cost using a 1-year reserved option for virtual machines, reserved instances, or you could have reserved capacity for databases. And you can see that if you combine that with the Azure hybrid benefits, you can get savings of up to 80% or so. So the consumption-based model, only pay for services when you use them, or the time between when you've added them into your Azure account and when you delete them from your Azure account. So that is the consumption-based model. Cloud services can be categorized in lots of different ways. One major way of categorizing them is by calling them IaaS, PaaS, and SaaS. All of these are different cloud services. We'll have a look in a few minutes as to what the difference between IaaS, PaaS, and SaaS are. But it would probably be first useful to have a look at the difference between on-premises and the cloud. So on premises, you know where your data is. It's in a big box which is sitting inside your building. And the physical location of your data, well, it's got to be limited to places that you own. So if I was in Birmingham, Alabama, and I have a big box, I couldn't necessarily have my data on premises in Australia unless I happen to have an Australian office as well. I'm in full control of my security. For better or for worse, that means that I've got 100% assurance of what the security is. I've also got 100% of the cost. With the cloud, You have to trust where the location of your data is. I say that I've uploaded it to the East US. Have I got definitive proof that it's gone to the East US? Can I go to a place and say, oh yes, that's where my data is, in this particular data center? Not really. I have to trust somewhere. But the location of my data could be worldwide. So if I'm sitting in the United Kingdom, I can put my data in Australia if I choose to. So if I choose to keep it in the UK, I can do. If I choose to duplicate it in the UK, in America, in Australia, that can be what I do. I have the choice. My data security, to a certain extent, has been offloaded to Azure. I do not have to employ people to physically guard the data centers. But the flip side is, I don't necessarily know what the security is there. I can read about it, it's fairly tight, but I have to trust in some way. So if it's on premises, I'm responsible for paying for the physical server boxes. If I wanted to upgrade memory, core, hard drive space, it would take planning. It would require the purchase of equipment. It would take, well, I've put here days and weeks, it would probably take months, to be honest. In the cloud, I rent the server. The cloud provider buys a physical server box. Because they're doing that in such quantities, they can get good discounts. And to upgrade the memory, core, hard drive space that my virtual machine is using, it's just a click of a few buttons, a few minutes, maybe a reset of the virtual machine, which is very quick in itself. So on premises, it's capital expenditure. In the cloud, it's largely operational expenses. On premises, I'm responsible for doing hardware maintenance upgrades. I'm responsible for doing software upgrades. On the cloud, then the Azure, the cloud provider, is responsible for doing any hardware maintenance. It's responsible for doing the hardware upgrades. As for software upgrades, that might be you, that might be Microsoft. It depends whether you're using IaaS, PaaS or SaaS. So in the next video, we're going to have a look at these 3 different solutions and compare it with on-prem, and it's only after that that we'll know whether it's us or Microsoft who is doing the software upgrades. So in this video we're going to have a look at the shared responsibility model, and it's fairly easy on premises. Everything is down to me. Buying the physical hardware, buying the operating systems, maintaining the operating systems, the database server software, any applications other than the operating system, the information, the data, any physical objects, the mobiles, the PCs, and IDs and user accounts. They're all my responsibility. It takes more administration to do that because I've got to do all of this. It involves higher capital expenditure costs because I've got to buy the physical hardware. But I have more features and I have more control. As we go down this line, I will have lower administrative effort. I will have no capital expenditure cost, but I may have fewer features and I certainly will have less control. So let's have a look at infrastructure as a service. With infrastructure as a service, the actual buying of a physical hardware and the operating system is gone. It's not my responsibility, it is now Azure's. However, everything else is down to me. So when we created that virtual machine, we logged into it. We could install programs. We could install database software. The operating system will be untouched by Microsoft, or at least by Microsoft Azure. You may, of course, have Windows Update, which will update the operating system, but if not, it's down to you. So I can specify Windows Server 2012 Release 2. It will put that in. Unless I've got Windows Update, that's the feature, that's the version that will stay. If I have on my virtual machine SQL Server 2017 Release Pack 1, it won't be upgraded to Release Pack 2 by Microsoft Azure. You will have to do it. It's your responsibility. When we get to PaaS, Platform as a Service, then the maintaining the operating system and the database server software will be gone. That again will be Microsoft Azure's. Now that can be good and bad. if you want a specific SQL server, for example, I need for my application 2012 release 2, I can't do that as a PaaS. I would have to do that as an IaaS. If I want that much control, I have to do an IaaS or on-premises. PaaS, you have an operating system by Microsoft built in. You have a database server, if that's what you're going for, built in. It will probably be the latest version. You won't be able to pick and choose. You may be able to add other applications. The information and data, the physical objects, user accounts or IDs, that's still your responsibility. And then we have software as a service. So the applications are now completely Microsoft Azure's. You are responsible at all times for data, for user accounts, and for physical devices. So you could have a metaphor of this for eating. On-premises is your eating at home. You are buying the oven, you are buying the food, you are buying the tables. For IaaS, you go out to a restaurant, but instead of getting the waiter and the chefs to cook the food, you cook the food. You go into the kitchen, you cook the food. So you don't have to buy the physical hardware, but you still have to maintain the operating system and so forth. You still have to buy the food, you still have to cook the food. In PaaS, you go to a restaurant and you give them the food to cook. So you no longer have to worry about buying the kitchen, you no longer have to worry about cooking the food. SaaS, software as a service, you go into a restaurant, the waiter brings you a menu, you select from the menu, and you get your food delivered to you. At all times, you're still responsible for paying the bill. You're still responsible for showing ID to ensure that you are old enough to drink. You're still responsible for bringing your glasses or spectacles along so you can actually see the food. So that is the shared responsibility model. As we go down, IaaS, PaaS, SaaS, more of the items will be Microsoft's responsibility. And as long as you are happy with what features and control are left, then that could be the responsibility category for you, for this particular service. And of course, you're not limited to one of these. You could have a virtual machine and you could have something in SaaS. We'll have a look at individual services in the next video. So what are the different types of services in real life? So on premises, these are your traditional servers. So you buy a physical device, you store it in your building, that is on premises. We've already seen an example of IaaS, a virtual machine. So you don't have to buy the physical item, but you rent everything else and you're responsible for its updates. With PaaS, we're no longer responsible for operating system updates. So for instance, a database might be a PaaS. It would be a specific database that Microsoft gives you. And then we've got plenty of examples of SaaS in real life. For example, do you use Gmail, Google Mail? Do you use Hotmail? Do you use Office 365? So do you log in and be able to use Word and Excel? Or maybe you've got a file sharing application like Dropbox. All of those examples of SaaS. Just ask yourself, what operating system do they use? No idea. Anything else about them? No, you've got no idea. All you know is how to connect to them. So examples in this course that we're going to have a look at, IaaS, we've got the Azure Virtual Machine, so you could install SQL Server on that. Other databases are largely PaaS. So you don't get to choose the operating system or the version of the database software. Then we've got the Internet of Things. The hub is PaaS, but the central is SaaS. We've got container instances and app services, which are PaaS, and DevOps services, which allows you to have a host of templates for virtual machines ready, and then your developer can say, I want to borrow this one for 2 hours. That is a SaaS. So IaaS, PaaS and SaaS. Largely we'll be looking at PaaS and SaaS, and they are a categorization of your cloud services with the shared responsibility model. In this video, we're going to have a look at public, private, and hybrid clouds. So let's start with a public cloud. So a public cloud is the standard cloud. It is operated over the internet and operated by a third party. So it can have multiple tenants. Those are organizations. So the public cloud word is tenant for that. So you can see advantages of public clouds: lower cost, no maintenance, you can scale up as much as you want, and high reliability. In a private cloud, it is exclusive to your tenant. It can allow for greater security, as it might be located in your own organization's data center. Alternatively, it could be hosted by a third-party service provider. Either way, it's always maintained on a private network and it's solely dedicated to you. Why might you want a private cloud? Well, it could be because you've got regulatory bodies requirements that say certain data must be private. So advantages of a private cloud: more flexibility, more control, and more scalability. Now, hybrid clouds are in between. They are a combination of public and something else. So it could be a combination of on-prem infrastructure with a private cloud, or it could be a combination of a private cloud with a public cloud. In a hybrid cloud, data and applications can be shared between them. So maybe you have data requirements that say that certain data must be kept on premises. The main problem with a hybrid cloud is increased IT support. You need people where you've got services which require both public and private cloud. Where you've got services that require public clouds, well, it's just like any other normal cloud. You can reduce the amount of IT support that's needed. If you've got private clouds, you need to increase the support, and if you've got data moving in between the two, that's even more support. So public clouds are the standard clouds, private clouds located in your businesses or hosted by a third party, but either way it is on a private network, and hybrid cloud involves both a private cloud and either a public cloud or on-premises infrastructure. In this section, we're going to start looking at the core resources available in Azure, and we're going to start with compute resources. So what will generally happen is I'll take you through the initial start of installation, and then we'll look at some literature about it, so where you can get further information. Now, I could spend quarter of an hour talking about each of these services, but that's not necessary for the AZ900 exam. What you need to know is what they are and some of the key features about them. So we're going to basically keep each of these many services running at quite a brisk speed, and then there'll be questions in quizzes so that you can make sure that you are learning what you need to learn. So we're going to start with that which we have previously looked at: virtual machines. So virtual machines are a form of IaaS. So you are responsible for the maintenance of the operating system and any programs. So it is a software emulation of a physical computer or a server in minutes, and you will have your choice of virtual processor, memory, storage, and networking. You'll also have your choice of operating system and software, because you'll be able to add whatever software you want. It's just a computer. Now, this can be added en masse using scale sets. So suppose I wanted 50 virtual machines. Well, I can do that using a virtual machine scale set. So if I go to scaling, for instance, you can see initial instance count is 2. I could start it at 50 if I so wished. Now, don't confuse virtual machine skill sets with Azure Dev Test Labs that we'll be looking at later. That is for allowing a set number of computers to be created and then uncreated. A virtual machine skill set actually creates the machine. So if I said 50, it would create 50 machines. So when would you want to use a virtual machine? Well, maybe there's a disaster on one of your computers and you just need a machine very quickly. Because you can power it up and power it down or deprovision it quickly, it can be great for testing and development. Maybe you are extending your network to Azure. So you have your on-premises network and you want to add additional capabilities. And then maybe a disaster happens and you suddenly need a virtual machine. It is great in Azure that you can have a virtual machine in as little as 5 to 10 minutes, and then you can install whatever programs you want. So you can have it as a per second billing. You can have thousands of VMs with the virtual machine skill sets. You can encrypt sensitive data, and you can choose Linux or Windows, or indeed any image that has previously been created by somebody else. So these are virtual machines. In this video, we're going to have a look at the app services. So the app services is a PaaS. So it allows us to deploy apps such as web applications coded in ASP.NET, PHP, Python, and many others. It's basically there to allow you to create apps running in the background or mobile backends for iOS, so Apple or Android devices. So for example, you could think of app data stored in an SQL database or authentic. authentication against Facebook and Twitter. Some of the advantages to app services are its performance. You can see enterprise grade performance. It's scalable. It's secure, so you can run it in an isolated and dedicated environment if you want. It's got rigorous security and compliance, so if you've got specific requirement, then it's usable for that. And it's highly available because it's got a built-in traffic manager and load balancing. Now, some of the web apps are included free. If we have a look at the list of services which are free and have a look for app, you'll see that we have 10 web mobile or API apps with Azure App Service with 1 GB of storage, always free. You can see further down that they have an SLA of 3.5 nines, and you can scale globally across all Azure regions. So Azure App Services, it's PaaS. It allows you to deploy apps such as those encoded in ASP.NET, PHP and Python. It's used for background jobs and for mobile backends. In this video, we're going to talk about Azure Container Instances, also known as ACI, and Azure Kubernetes Service. So what are container instances? Well, sometimes you don't need a full virtual machine. You just need that which is needed for a particular app. So the process of having everything that an app needs to run and nothing more is called containerized. So these are virtual lightweight operating systems that you don't manage. The operating system can be on Windows or Linux. They can be stored in the Docker Hub. So this is a container engine supported by Azure, one of the more well-known ones, or in the Azure Container Registry. You can also see we've got some quick start ones as well if you want to experiment. Because it's not a full-scale operating system, it can be a lot quicker to launch than VMs. And you can scale out and stop whenever is needed. So you can see that you can restart on failure or whenever a container ends or never. It is isolated, so each instance is separated from each other. So if it stops, then you won't necessarily have any idea in the second container what happened in the first. You might, for instance, need to read where you are from a database. Or you can use file share for persistent storage. So file share allows for multiple containers, for instance, to be able to read a file, maybe some data. So you can see it offers per second billing. This is how quick container instances are supposed to be, or at least can be. So develop apps without managing virtual machines or having to learn new tools. You can focus on designing and building your applications. Now, Azure Kubernetes Service allows you to orchestrate these containers. So instead of just having one container, you can have a large number of containers. So Kubernetes Service allows you to create and manage what they call pods. These are one or more containers, and it does this on cluster nodes. It can also handle storage and networking, so we're talking about making sure that there is sufficient load in each section of the pod. So more information appears that needs to be processed, it goes to one of the ACIs, the container instances. It can scale manually or automatically, so if you need more nodes, if you need more pods on the nodes, then that can be changed automatically. So this is horizontal scaling. It can also network isolate all of these pods so they are independent of each other. So Azure Container Instances This is an app with a lightweight operating system, either Windows or Linux, that's virtualized. It's quicker to run than VMs, and it can be created, scaled out and stopped when needed. You access it using the fully qualified domain name. So here we have a URL. So fully qualified domain names usually a lot longer than that, but similar idea. Docker is a container engine supported by Azure, and it is build per second. So these are ACIs, container instances, and AKS, the Kubernetes service. Now, suppose you don't want virtual machines, but you want everybody to be able to log into Windows virtually. Well, this is when the Windows Virtual Desktop might be of use. So this is a cloud-hosted version of Windows, and it uses the Windows 10 Enterprise multi-session, and this allows multiple concurrent users on a single virtual machine. Now you can access remote desktops and apps, so you can have your own workspace. So you can see you can register your default application group. Now you can access your Windows Virtual Desktop obviously through Windows, but you can also do it through Mac, through Linux, through an Apple iOS, or through Android devices. Now your user profiles are persisted through sessions. However, you can also have individuals owning their own persistent desktops. If that's the case, then they would be able to add or remove programs on that remote desktop. Now, because this is Azure, you get all of the features of Azure. For example, you get Azure Active Directory. That's how you are able to log in to Azure. So you've got centralized security. You've got access to data using role-based access control, so you can fine-tune who has access to what. Now, one of the advantages of Windows Virtual Desktop is that the app and the data are separated. So there's a lower chance of confidential data being on personal drives. They, by necessity, will be on a shared storage. And you can reduce the cost with existing licenses. So if you've got your own Windows licenses, if you've got your Microsoft 365 licenses, you'll be able to use them. So it is a cloud-hosted version of Windows using Windows 10 Enterprise multi-session that you can access from Windows, Mac, Linux, iOS, and Android devices. In this video, I'm going to talk about Azure Functions, and in the next video I'll be talking about Logic Apps and then trying to distinguish between Azure Functions and Logic Apps. So Azure Functions, these are small pieces of code. They are event driven. So for instance, you might have it running on a timer, so every hour, every minute. It might be that there is a request to run, your message from another service, or it might be that there is a web request, and these are called webhooks. So these web requests, HTTP callbacks, they're called webhooks. You might hear that terminology. So these are all event-driven calls. So it could be run on a trigger, so again a schedule. It's serverless. So what do we mean by serverless? We don't mean it doesn't have a server. It means that the server is something that you do not control. Azure sets it up for you. Now, the functions are small pieces of code, and the code can be written in things like C#, Python, Java, JavaScript, but you will need a program to run the custom code. Now, this code generally is for functions that run in seconds, or maybe even less than seconds, maybe even part of seconds. Now, some of the advantages of functions is that you are only billed for the resources that you use. So it's good when the demand is variable. You can scale automatically, so you can have hundreds of functions working at the same time, or indeed 0 if there's no instant demand for it. Now, these are generally stateless functions, so they act as if the 100th time is just the first time. It's like they're doing it afresh. They don't carry things over from the previous time. However, you can have them to be stateful as well, also known as durable. This means that prior activity context is maintained. For that, you'd need to connect your functions to Azure storage so that when a function ends, it can save what it's got. And you can run locally or on Azure. So Azure functions. These are small pieces of code which can be run in seconds or less than seconds, but you will need a programmer to write the custom code for, say, C#, Python, JavaScript or Java.